Across agricultural landscapes worldwide, bird populations are declining, not gradually, but consistently. In many regions, species that were once common in farms, insect-eating birds, ground-nesting birds, even seed dispersers, are now either reduced in number or completely absent. And for most landowners, this change goes unnoticed, because the system still appears to function. Crops grow, fields are managed, inputs replace what is missing. But what has actually changed is the biology of the system itself. To understand this, we need to first understand what birds actually do in agricultural ecosystems. Birds are not just part of biodiversity. They are active participants in energy transfer, pest regulation, and ecological balance. A large number of farmland birds are insectivores. They feed on caterpillars, beetles, grasshoppers, and other herbivorous insects, many of which are primary crop pests. This feeding is not occasional. It is continuous. During breeding seasons, a single bird can consume hundreds of insects per day to sustain itself and its offspring. Now scale that across a population. What you have is a distributed, self-regulating pest control system. Remove that system, and insect populations are no longer regulated biologically. They become dependent on chemical suppression. Birds also interact with seeds and soil systems. Some species contribute to seed dispersal, moving plant species across landscapes. Others feed on weed seeds, reducing the seed bank in the soil. And ground foraging birds disturb the soil surface, which can influence microbial activity and nutrient cycling at a microscale. So when birds disappear, what is lost is not just diversity, but multiple functional roles that support agricultural stability. Now the question is, why are they disappearing? The primary driver is habitat simplification. Modern agricultural systems tend to remove non-crop elements. Hedgerows are cleared, tree lines are removed, field margins are reduced. From a management perspective, this increases efficiency. But from an ecological perspective, it removes nesting sites, shelter, and food diversity. Birds require structural complexity in the landscape. They need places to nest, areas to hide from predators, varied food sources across seasons. When farmland becomes uniform, it becomes biologically poor, and birds cannot sustain themselves in such environments. The second major factor is chemical exposure. Insecticides reduce insect populations directly. This creates two layers of impact. First, birds lose their food source. Second, they are exposed to toxins through the food chain. Sublethal exposure can affect reproduction, egg viability, navigation, immune function. So even when birds are present, their populations may not sustain over time. Herbicides also play a role. By eliminating non-crop vegetation, they reduce seed availability and habitat diversity. This further simplifies the ecosystem. Another factor is timing mismatch. Agricultural cycles are increasingly synchronized for efficiency, but bird breeding cycles depend on food availability. If peak insect populations do not align with breeding periods, chicks do not receive adequate nutrition. This reduces survival rates. There is also the issue of nesting disruption. Frequent mechanical activity, plowing, mowing, harvesting, can destroy nests, especially for ground nesting species. Over time, this reduces reproductive success. When all these pressures combine, habitat loss, chemical exposure, food reduction, and disturbance, bird populations begin to decline. Not suddenly, but steadily. Now here is where this becomes directly relevant to agriculture. When birds decline, the system compensates, but not in a balanced way. Insect populations become more volatile. Without biological regulation, they can increase rapidly under favorable conditions. This leads to sudden pest outbreaks, increased dependence on pesticides, higher input costs. At the same time, the absence of seed-eating birds allows weed seed banks to accumulate. Over time, weed pressure increases, So what appears to be a biodiversity issue is actually a system stability issue. And this is where the deeper misunderstanding exists. Most agricultural systems are designed around inputs. Fertilizers replace nutrients, pesticides replace pest control. But biological functions are not easily replaced. They are interconnected, adaptive, and continuous. Birds are part of that biological infrastructure. They operate without external input. They respond dynamically to changes. And they regulate systems in ways that are difficult to replicate artificially. So the real question is not how to bring birds back as an isolated goal. The real question is, what kind of agricultural system allows birds to exist in the first place? Because birds do not return to managed land. They return to functional ecosystems. This means reintroducing structural diversity, not as decoration, but as system design. Tree lines, hedgerows, buffer zones, and undisturbed areas create nesting and shelter conditions. Reducing chemical dependency allows insect populations to stabilize, which restores the food chain. Maintaining ground cover and organic matter supports insect diversity and soil life, which indirectly supports bird populations. And allowing parts of the land to remain less disturbed during critical periods supports breeding cycles. None of these are isolated actions. They are system-level decisions. Because once a biological function is removed, it is replaced by management effort. And over time, that effort becomes dependency. So the disappearance of birds from farms is not just an environmental concern. It is an indicator. An indicator that the system is becoming more artificial, more input-dependent, and less resilient. And if that trajectory continues, the cost of maintaining productivity will continue to rise. So the question is not whether birds are important. The question is, what does their absence tell you about the system you are building? Because in stable agricultural systems, biology does most of the work, and birds are one of the clearest signs that that system is still functioning.